Problem number 3. We want to prove that angle HDE is congruent to HDF. And first of all, what we're given that DE is congruent to DF. And the second piece of given information is that angle EHD as well as angle FHD are right angles. So our third step here is to say that HD is congruent to HD, which means HD is congruent to itself. We can mark that up in our picture, and our property is the reflexive property. And we actually have enough information now to prove that our triangles are congruent. You can say that triangle EHD is congruent to triangle FHD. And what we have is we have a right angle in this one. And because we have a right angle, across from the right angle is the hypotenuse. And then we also have an additional leg. So this is the hypotenuse leg. By the way, across from the right angle is the hypotenuse there. I'll abbreviate this time. So we have the hypotenuse and we have a leg. So our two triangles are congruent, which means that we can finish with corresponding parts of congruent triangles are congruent, because once we prove the triangles are congruent, then all of the parts are congruent. Flipping our page, problem number 4. We're proving that triangle NEU is congruent to triangle MBU. So when we look at this picture, let's mark up our given information. And what we know is that NEU is congruent to MBU. And we also know that NU is congruent to MU. So we've got an angle and we've got a side so far. Well, what we can also say here is that this angle and this angle are congruent. So let's say angle NUE is congruent to angle MUB, because we're working with the vertical angle theorem. And that gives us enough information to be able to say that the triangle on the left, we've got to be able to see it, the triangle on the left and the triangle on the right are congruent. And the reason is we've got an angle and a not included side, an angle and a not included side, and that is angle, side.